There's a technology that almost nobody talks about publicly. It wasn't unveiled at high-profile trade shows and hasn't become the subject of press conferences. But it's precisely this technology that could destroy an industry that over the past decade has become one of the most expensive markets on the planet. Lithium has ruled the world of electric vehicles, and now something is quietly preparing to take its place. For more than 10 years, lithium was considered the undisputed foundation of the electric vehicle revolution. It powered factories, shaped supply chains worth hundreds of billions of dollars, and turned companies into global giants. Experts were convinced that lithium would dominate for many years to come. But behind the closed doors of laboratories, something completely different was unfolding. According to emerging research, scientists around the world, including teams linked to Tesla, are studying a technology capable of making lithium batteries as outdated as coal power plants became in the face of nuclear energy. This isn't just another improvement to existing chemistry. It's a fundamentally different approach to energy storage, built around aluminum. Aluminum is one of the most abundant and cheapest metals on Earth. It's mined everywhere, processed on an industrial scale, and the infrastructure for working with it already exists globally. It's not a rare resource concentrated in the hands of a few states. It's a metal that literally surrounds us. And this is exactly what makes the aluminum-ion battery potentially disruptive to the entire existing system. So what does this technology actually look like in practice? A traditional lithium-ion battery has a certain ceiling on energy density. Aluminum-ion technology, according to researchers' claims, is capable of exceeding this figure many times over. This isn't a gradual increase, it's a qualitative leap into a different category of energy storage, but energy density is just the beginning. The new battery, according to available data, operates across a significantly wider temperature range. This means that the bulky cooling systems that today take up space and add weight in every electric vehicle become simply unnecessary. The problem of dendrites also disappears, microscopic metallic growths that gradually destroy lithium batteries from the inside. And along with them goes thermal runaway, the phenomenon behind the battery fires and explosions that have worried electric vehicle owners for so long. The fears that have held back mass adoption of electric vehicles for years are disappearing. In their place comes a battery that isn't just safer, it's smarter, more durable, and fundamentally different by nature. The claimed lifespan deserves particular attention. Ordinary lithium-ion batteries are designed for several thousand charging cycles. Aluminum-ion technology, according to available information, is capable of withstanding tens of thousands of cycles. Its estimated service life could reach several decades, longer than many people live in the same house. The battery could outlast both the car itself and its owner. On top of that, there are reports of a deep sleep function. The battery is said to be able to hold its charge with virtually no losses over many years. Imagine leaving your car in the garage for a long stretch of time, and when you come back, it's ready to drive as if it had just been charged yesterday. There's one more feature that sounds almost like science fiction, yet it's exactly this that's attracting the most attention from researchers. The battery, according to available data, is capable of self-repair. Microscopic damage that inevitably builds up over repeated charging cycles gets automatically fixed inside the cells. Instead of gradually degrading, the battery continuously restores its own structure. This means the end of planned battery obsolescence, one of the most painful and costly problems in today's electric vehicle market. The financial implications are no less significant. Today, the battery pack is one of the most expensive components of a typical electric vehicle. According to forecasts, an aluminum-ion equivalent could cost substantially less, potentially cutting the final price of an electric vehicle by around a fifth. This opens up the possibility of genuinely affordable electric cars without sacrificing performance, and the recycling rate of aluminum-ion batteries is expected to approach 95%, compared to the significantly lower figures for current lithium systems. Now let's take a look at the bigger picture. Global lithium supply chains represent massive investment. States, corporations, and investors have spent years pouring money into the mining, processing, and transport of this metal. If aluminum-ion technology reaches mass production, a significant part of this infrastructure will be at risk. Cobalt, another key component of modern batteries, mined under serious environmental and ethical risks, could turn out to be simply unnecessary. Long-term contracts built around these materials will sharply lose value. Countries that control today's lithium reserves risk losing their geopolitical advantage. This isn't just a shift in technology, it's a redistribution of global influence in energy. Financial markets, it seems, are already reacting. Some investment funds have started directing capital toward companies working on aluminum-ion developments without waiting for official announcements. This isn't panic or hype, it's the cautious repositioning of those used to staying one step ahead of the market. The application of this technology isn't limited to cars. The same chemistry could power drones, ships, aviation, home energy systems, industrial storage, and urban power grids. During power outages, an electric vehicle with this kind of battery could become a full-fledged mobile power plant for a home or even an entire neighborhood. Remote areas that have depended on diesel generators for decades would get the chance to switch to clean, self-sufficient energy without large-scale infrastructure construction. What's especially notable is that this transformation is happening quietly, without loud press conferences, without triumphant headlines. Progress is showing up through testing programs, expanding production, and gradual rollout. According to available data, prototypes are already being tested, hidden inside cars that look completely unremarkable on the outside. While traditional manufacturers keep pouring billions into refining lithium technology, slightly faster charging, slightly more range, part of the industry, it seems, is already building an entirely different foundation. By the time competitors realize the scale of what's happening, the gap may prove impossible to close. Lithium won't disappear overnight. It will remain in the market for a long time, like many outdated technologies that keep working but stop being the obvious choice. This is exactly how broadband internet displaced dial-up, not through a ban, but through superiority across every key parameter. Aluminum-ion technology didn't arrive with fanfare. It arrived with the potential to overturn everything the industry considered unshakable: lower production costs, increased safety, reduced dependence on contested supply chains, a vastly greater lifespan. This isn't a routine engineering solution. It's a claim to change the very foundation itself. And if this transition picks up speed, companies that bet on lithium as an eternal standard could find themselves in the position of those who built the world's finest cassette decks just as digital audio was emerging. We're not witnessing a smooth evolution of technology. We may be witnessing the moment after which the clock starts over from zero. If you're interested in following how this story unfolds, subscribe to the channel and hit like. There's a lot more ahead that most people don't even suspect yet.